Hello everyone, and welcome to our submission for the Qiskit Fall Fest Hackathon. Our project is a quantum radar for Battleship, and we have built a quantum algorithm that uses interaction-free measurement to find a hidden ship without even hitting it. The challenge was to reinvent Battleship using quantum mechanics. Our goal is to detect a 2-unit ship on a 4x4 grid. Our success is measured by EV score, which is Elitzer-Weidman score, which is the total number of successful detection divided by the total ship hits. A perfect score is infinity, which means we find the entire ship with 0 hits. This is what we are aiming for. To achieve this, we have implemented an advanced bomb tester using the quantum Zeno effect. Here is the core idea. We have a probe qubit that we try to rotate from state 0 to state 1. If there is no ship, it rotates freely. But if a ship is present, our circuit creates a tiny interaction that nudges the qubit back towards 0 every time it tries to rotate. We run this rotate and nudge process 15 times. This gives us a very clear signal. If we measure the probe as 1, it's a miss. But if we measure the probe as 0, it means it was frozen by the ship's presence, and that's a detect actually. This slide shows the two circuits we have built, and with this really highlights why our Zeno algorithm is superior. At the top we can see the baseline circuit. This is a simple destructive interferometer, and at the bottom we have the Zeno circuit. We can see it have the repeated blocks for each Zeno iterations, and here we have just shown for the 3 iterations, as these are just for the visualization purpose. Now let's switch to the code to show the critical difference between these two. Here is our code, and this is our baseline circuit code. So look at the end. We measure the probe, but we also measure the state qubit. This act of measuring the state is the hit. This is what we must avoid. Here is the code for the Zeno circuit, and here we build the circuit for the 15 iteration, and we have the weak rotation Ry, the oracle check, and the CZ interaction. But here is the most important part. Look at the very end of the function QC measure. We only measure the probe qubit. The state qubit that represents the ship are never measured. This is the key to our entire interaction free strategy. So now the question is, how do we use this circuit to play the game? We developed a two-stage radar strategy. In stage 1, we scan all the 4 rows to find the rows of interest. In stage 2, only for those interesting rows, we then scan each of the 4 columns. This is an efficient way to pinpoint the exact coordinates. Let's see this in the code. So here is our Zeno game class. It is very straightforward. The stage 1 rows function just loops for r in range board size and runs our Zeno guess on the row self.board. Then stage 2 columns loops through the columns for c in range board size, but only for the rows we found in stage 1. It scans the full column vector self.board. This two-stage logic let us find the ship, and our EV score is based only on this stage 2 detection. Now for the exciting part, the results. First, I will run the single game demonstration. I will just run this cell. Look at this. The true ship is at 0, 3 and 1, 3. These two squares. Our baseline algorithm got an EV score of 0.45 because it had 825 hits. But our Zeno algorithm, it correctly founds the cells 0, 3 and 1, 3 with 0 hits, giving it a perfect EV score of infinity. But one game isn't enough, we must prove it's robust. So I will run the robustness cell. This runs both the algorithm on 100 random boards. This test is creating 100 random boards and having both algorithm try to find the ship it collecting the scores for each and every single run. And here is the final proof. Look at the summary statistics. The baseline algorithm had over 80,000 total hits to find the ships. Our Xeno algorithm, 100 out of 100 perfect scores. It found all 200 ships segments with 0 total hits. This robustly proves our Xeno algorithm is a perfect implementation of the challenge. So, as the demo just proved, our results are conclusive. The baseline is inefficient and destructive with EV score of around zero point 0.5. Our Xeno algorithm achieved a perfect infinite EV score on all 100 trials. It had a 100% success rate with 0 hits. In conclusion, our quantum radar leveraging the quantum Xeno effect successfully demonstrate a practical Ellinger-Weidman bomb tester. So we achieved the core objective, like detecting the ship without interacting with it, delivering a provable quantum advantage over a classical or destructive methods. Thank you.